There are two questions given here, but in exam you can choose either first question or second question. Let me explain both here. First we'll start with question A, the first question. Here the question is what is solar cell and draw its VA characteristics and also explain three processes involved in its working. So first let us discuss what is solar cell. Solar cell is basically a semiconductor device. We know that the semiconductor device which is a p-n junction diode. So let us take this is P region, N region, and we have top surface and the lights. So here this is top surface of the cell. So the solar cell which basically converts light energy into electrical energy by using the concept of photovoltaic effect. Now solar cells are the fundamental building block of solar panels and are widely used for generating renewable energy. Now let us discuss the VE characteristics of a solar cell. Now we are going to take the voltage in the x-axis and the current in the y-axis. So now we have VOC and the short circuit current ISC. So we'll get the curve like this because ISC is the short circuit current when the load resistance RL is 0 and VOC is the open circuit voltage when the load resistance is infinity. So now we'll discuss about three processes involved in its working. The first process is generation. In this, electron-hole pair will be generated due to the light close to the junction. So electron-hole pair is generated due to light close to the junction. Now the second process is separation. In this process, electrons and holes will be separated due to electric field of the depletion region. Electric field of the depletion region. Now the third process is collection. In this process, electrons reaches N side which is collected by the front contact and the holes reaches P side or collected by the back contact. So P side will become positive and N side will become negative. So this gives you rise to photovoltaic. So these are the process involved in solar cell working. Now let us discuss second question, that is B. Here the questions: draw the circuit diagram of a full wave rectifier. Explain its working showing its input and output waveforms. So first let us take the circuit diagram of a full wave rectifier. So full wave rectifier has a center tap transformer. So we'll be taking the center tap transformer first. Then we have diodes. And we have one more diode here. So let us take this is D1 and D2. Now we have the output unit. So from here, so we'll get the output unit RZ, so which is output, and let us take this point as X and this is Y. So here we have the point A and B. So this is the center tapped transformer. We can call it a center tapped transformer, CTT. Okay. So this is the circuit diagram of full wave rectifier. Now we'll discuss about the working of full wave rectifier. So there are two cycles we have in this one. The first one is positive half cycle and the other one is negative half cycle. During the positive half of the AC input, So here the input is AC, positive half of the AC input. Diodes D1 conducts and D2 is reverse biased, which means D1 is forward biased, D2 is reverse biased. So only D1 conducts and D2 will block it. So now second one is a negative half cycle. So during the next half of cycle of the input AC signal, D2 is forward biased and D1 is reverse biased. Now because of this center trap transformer, the current in the loop flows in the same direction during both half of cycle. Now let us draw the input and output waveform. So first let us draw input waveform, then we'll draw output waveform. See here the input waveform is a sinusoidal AC waveform. So it will be like this. So this is the input waveform. So which is sinusoidal AC waveform. Right, now let us draw output waveform. In this thing we have output waveform. Let us take this is T and this one. So output waveform across RL. So here we'll get the wave like this. So again, this is due to D1, again this is also due to D1 and D1 and so on. So from this we can say that the input AC waveform consists of alternating positive and negative cycles. This converts both half of the AC signal into a pulsating DC output. So the direction of the current will be same.